Yes, I would like to acknowledge Mr. Shubham Sutar for the inspiration behind my attempt. My version builds upon his original idea with a few enhancements, and I am really grateful for his contribution. Here's a snapshot of his clock in action. In his video, he walks through the complete process of building the circuit and explains how the clock works. It's highly recommended that you watch his video first before continuing with mine. You'll find the link to his video in the description below. Pay close attention to the pin configuration of the 16x2 LCD and the way its pins are connected to the Arduino. Here's a snapshot of my clock taken when it was running. You can see the differences right away. First, I've moved the digits showing the seconds to the center of the display, between the hour and minute digits. As the clock runs, the seconds digits will increase progressively. All the months are now displayed properly in words, while the dates are shown in digits. The most noticeable difference is in the number of push buttons. Instead of 3, I've used 4 pairs arranged in 2 rows, along with 1 additional separate button. The red single button pauses the clock when pressed, allowing you to set the time. Pressing it again resumes the clock with the updated time. The buttons on the top row function as up buttons, while the bottom row buttons act as down buttons. Pressing the top buttons increases the digit values for the hour, minute, month, and day respectively. Likewise, the buttons in the bottom rows are used to decrease the corresponding values of the digits. There is a reason for using these separate buttons to increase and decrease the values of hours, minutes, months, and dates. Because these push buttons do not show firm and positive responses when they are clicked, many times you have to press several times to get a positive response in a button. With separate buttons, we can change the values independently, and we know for sure what value we are changing. There is no need to press the Set Resume button several times in between to move from hours to minutes, minute to months, etc. After setting the desired values, one more press of the Set Resume button will resume the clock. There isn't much change in wiring, except for the extra wiring to connect the additional push buttons. Pins 8 to 13 are used as inputs, and the analog pins A0, A1, and A2 are also configured as inputs. Now you can see the running clock. The digits for second increase after each second. This indicates that the clock is running. Whenever you want to adjust the time, press the Set Resume button once and note the flashing question marks in place of second digits. This question marks insist that the clock is in set mode so that you can adjust the digits. Now, press and hold the top blue button. You can see the increase in the hour digits. When you press and hold bottom blue button, the values in the hour digits decrease. When the top green button is pressed and held, the values of the minute digits increase. When the bottom green button is pressed and held, the values of the minute digits decrease. The top yellow button causes the months to increase. The bottom yellow button is used to decrease the months. Similarly, the black buttons are used to increase or decrease the dates. You would have noticed when September is being displayed, you cannot set the date to 31st, as September doesn't have 31 days. But for October, the date can be set to 31. This feature is looked after by the code, which I will go through later. Make sure to adjust the date after the desired month is set, not the other way around. Other than this restriction, you can adjust the other digits in whatever the order or whatever the value you want. Once the desired values are set, you press the Set Resume button for the second time. The clock will resume to run. When the clock resumes, the second will be reset to 0. So, if you want only to reset the second, you can just press the Set Reset button twice. That is it. It is so simple and smart way to adjust the desired time in the clock. Now we will go through the code. That is the acknowledgement again to Mr. Shubham Sutar. Here the library for the 16x2 liquid crystal is included. In my circuit, the register select and the enable pins are connected to the pins 7 and 6 of the Arduino, respectively. 4 pins of the least significant data bits from the LCD are connected to pins 5, 4, 3, 2 of the Arduino, respectively. All the variables have meaningful names, like hour, minute, second, etc. Names of the months are kept in a string array called months, and a needed month is fetched using the variable called monthIndex from this array. The last dates of each month is stored in another array called lastDate. As I said earlier, this variable is used to ensure whether the 30th or the 31st is the last date of a selected month. The Boolean variable set mode will be set to true when the set or resume button is pressed. Then the program will pause the clock and goes to a subroutine where the time is set as we checked earlier. Now, as the comment says, defining 8 arrays to create customized LCD segments that are turned on to display the big digits of the hours and minutes, the instructions in the line numbers 17 to 110 are written to create appropriate customized LCD segments. As you noticed, the digits of the hours and minutes are big. Each digit is produced by turning on appropriate segments from 2 rows and 3 columns. Each of these 8 arrays contains binary data to produce a customized segment, and later these segments are arranged in such a way to display the digits when they are turned on. Complicated? No worries. There is an article which covers a comprehensive detail of the 16x2 LCD. I have given the link to this article in the description below as well. You can fetch it and read. It is very interesting, and you will get a very good insight knowledge of this LCD panel. The binary data for each customized LCD segment are stored in byte-type array variable called bar. 8 different segments are defined and stored in 8 different arrays named as bar 1, bar 2, bar 3, and so on. Here in the setup section, as I said earlier, all the 8 digital and 3 analog pins are configured as input. Then the 8 byte-type arrays are stored in the available 8 locations of the random access memory of the LCD. The locations are named as 1, 2, 3, and so on, and these numbers are used to fetch the binary data. Here, the initial values for clock digits are assigned. Any appropriate values can be assigned. I assigned 0 for the hour, minute, and second. Month index is set to 1 so that it can fetch the string for the January from the array months. The date is set to 1. When the clock is started, the time will start using these values. Here onwards, some functions have been coded to display the numbers 0 to 9 at desired column in the display. As you see, the first function is named as display0. When this function is called with an appropriate column value through the variable col, the correct customized segments will be turned on at that column in row 0 and 1 to display the 0. Note the number in the parentheses of the lcd.write commands. The numbers here are 2, 8, 1, and 2, 6, 1. These numbers refer to the locations of stored bytes for the customized segments in the random access memory of the LCD. In similar way, more functions have been written appropriately to display each of the numbers from 1 to 9 at desired column. As you see, they are named as display 1, display 2, display 3, and so on to display 1, 2, 3, etc. This is another function called select display. While the clock is running, another section of the code determines which digit should be shown and in which column. At that point, this function is invoked with two variables, the digit to display and the column. Based on these inputs, this function then calls the corresponding display function with the specified column. This will be the main loop function which will be executed when the clock is running. The instructions inside this loop are executed repeatedly after every second. But you can see this loop can be interrupted when the set or resume button is pressed. When the set or resume button is pressed, the analog pin A2 will go high. This causes to fire another function called setButtonPressed, which handles the time setting. Otherwise, the execution will go down to check some important instances before displaying the digits. When the clock is running, for every loop, only the second is increased by 1. Then the variable second is checked whether it is increased above 59. If it's so, it will be set to 0 and the variable minute is increased by 1. Then if the variable minute exceeds 59, it is set to 0 and the hour is increased by 1. When the variable hour exceeds 23, it is set to 0 and the date is increased by 1. If the date exceeds the last date of the current month, it is set to 1 and the variable month index is increased by 1. When the month index exceeds 12, it is set to 1 again. This is the place where hour and the minute digits are evaluated and the column number is assigned to them. First, from the current value of the variable hour, the most significant figure is extracted and column number 0 is assigned to it. Then, the least significant figure is extracted and column number 3 is assigned to it. Secondly, from the current value of the variable minute, the most significant figure is extracted and column number 7 is assigned to it. Then, the least significant figure is extracted and column number 10 is assigned to it. In each case, the function selectDisplay is called with the variable digit and the column number. Since the second, month, and date are displayed in normal alphanumeric characters, printing them is straightforward. The most significant figure of the second is displayed at 6, 0, and the least significant figure of the second is displayed at 6, 1. The month string is displayed at 13, 0. The most significant figure of the date is displayed at 14, 1, and the least significant figure of the date is displayed at 15, 1. We have come to the final portion of the main void loop. Look at the lines 365,
366, and 367. Here, the second variable is increased by 1. Then, execution is delayed for 1 second before going for the next loop. Now, we will look into the subroutine which is fired when Set Resume button is pressed to set the clock. This subroutine is named as Set Button Pressed. Look at the lines from 373 to 385. Remember the Boolean variable set mode? Yes, it is set to true. A while loop is initiated to loop until this set mode variable is true. This keeps you in the time setting process until you press the Set Resume button again. Then, the second digits are replaced by 2 flashing question marks to inform you that you are in the clock setting mode.
Now look at the lines from 387 to 397, which are used to increase the hour digits. When you press and hold the blue color Hour Up button, the pin number 8 of the Arduino goes high. Then the hour digit is increased and displayed.
Now, I believe you can examine the rest of the code yourself. Observe which Arduino pins go high when the other buttons are pressed and held. Review the instructions to see how they increase or decrease the digit values and how each digit is associated with the correct column number.
We have come to the last portion of the subroutine. Line 468 checks whether you press the Set button again. If it is pressed, the second is set to 0 and the Boolean variable set mode is assigned to false, so that execution comes out of the while loop to return to the main void loop to run the clock again. Each character on the LCD is displayed using a small grid of pixels arranged in a 5 by 8 pattern, that is 5 pixels wide by 8 pixels tall. To create our own character, we must decide which of these tiny dots should be turned on and which should be off. But each of our clock digit is 3 characters wide and 2 characters tall. So, in an LCD character position, we have made only a segment of our digit. We have created 8 such segments. To customize a segment, we made 8-byte array in our code. Each byte in this array represents one horizontal row, starting from the top row and going down to the bottom row.
In each byte, we use the bits, the ones and zeros in binary, to indicate which pixels should be on, that is 1, and which should be off, that is 0.
Only the first 5 bits of each byte are used, since the character is only 5 pixels wide. To display 0, the segments must be arranged this way. So we have written the code like this. To display 1, the segments must be arranged this way. So we have written the code like this. Numbers appear in LCD.write are RAM locations in the LCD where the arrays are stored. 32 is the ASCII code for space. For the most significant figure of the hour, C equals 0. For the least significant figure of the hour, C equals 3. For the most significant figure of the minute, C equals 7. For the least significant figure of the minute, C equals 10.
Thank you for watching this demonstration. I hope you found it interesting and learned something new. If you enjoyed the video, please give it a like and share it with others who might find it useful. I'd love to hear your thoughts, so feel free to leave your questions or comments below. And if you'd like to see more science content like this, don't forget to subscribe and hit the notification bell so you won't miss future videos. Thanks again for your support, and see you in the next demonstration.